Okay. So now, in previous lecture, I told you comparison test and limit comparison test. This is now new test that is known as the Cauchy test, or this is known as Cauchy condensation test. With the help of this, you can also check whether a given series is convergent or divergent. What it says if an is greater than equal to 0 and an plus 1 is less than equal to an for all n. Obviously, n is the natural number a1, a2, a3. This is obvious. You write or you may write or not. It is not a problem. Then it says series this n is equal to 1 to infinity an converges if and only if and only if this series k is equal to 0 to infinity 2 raised to power k a to k converges. This is the test. This is known as the Cauchy test. It says if all terms are non-negative and this is a decreasing, an plus 1 is less than equal to an. If an converges, if and only if this is converges. It means if this converges 2 raised to power k a to k converges, then an converges. If it diverges, then it also diverges. Contrapositive. This does not converge, so it means this is if and only if this is does not converge. So whatever this have the nature, the same will have the same nature series n is equal to 1 to infinity an also will have the same nature. So now example, so I will prove the harmonics series with this example. Suppose you have a series n is equal to 1 to infinity n is equal to 1 to infinity 1 n raised to power p. I will prove that this is converges when p is greater than 1 or it diverges when p is less than 1, which is the harmonic series. So here first you take k is 0 to infinity 2 raised to power k a to k. So first is what is an? An is 1 power p. You can write one more thing before writing this. And an is greater than equal to 0 for all n and an is decreasing. Now, you find summation k is equal to 0 to infinity. Now you can apply Cauchy condensation test. First check what is this 2k a 2k. So this is summation k is equal to 0 to infinity 2k a to k. This will be n. So it will be 2k raised to power p. Or if you do some calculation, this is k is equal to 0 to infinity 1 upon 2 k p minus 1. Or you can write series k is equal to 0 to infinity 2k a 2k. So this is actually series k is equal to 0 to infinity. What is this? This is 2kp minus 1. If you open this is k is equal to 0, 1 plus 1 upon 2p minus 1 plus 1 upon 2, 2p minus 1 plus and so on. Suppose this is 1. So you can say this is a GP. Clearly, series k is equal to 0 to infinity 2ka 2k is GP, geometric progression, with common ratio, that is 1 upon 2 p minus 1. Or I have proved, if you have a GP, common ratio, you can just suppose this is R. If you have a GP, R की power n, so if this is converges, if R is less than 1, diverges, R is greater than equal to 1. Okay. So now make case first. Case first, here if p minus 1, this is p, if p minus 1 is greater than 0, so that is p is greater than 1. If p minus 1 is greater than 0, p is greater than 1, so this common ratio r 1 upon 2 p minus 1 positive, so this will be less than 1. R less than 1. So if you have a GP with common ratio less than 1, so you can say series k is equal to 0 to infinity 2k a 2k converges. So by Cauchy test, this series n is equal to 1 to infinity 1 by np converges. So it means if p is greater than 1, this is converges. Now case second, we have taken p minus 1 is greater than 1, 0. So p minus 1 is equal to 0. Then p is equal to 1. So what will be r? R is equal to 1 upon 2 p minus 1. So this is 1. So we have a GP whose common ratio is 1. So you can say this series k is equal to 0 to infinity 2k a 2k. This is diverges. So by Cauchy test, you can say this series n is equal to 1 to infinity 1 n raised to power p also diverge. So we have taken two cases when p minus 1 is greater than 0 is equal to 0, and third case is when p minus 1 is less than 0. If p minus 1 is less than 0. If this is less than 0, then you can p is less than 1. So what will be your r? 1 upon 2 p minus 1. So less than 1, negative p minus negative, so I think this will be greater than 1. If you have a GP whose common ratio is greater than 1, so you can write that converges 2k a 2k. This is diverges. So by Cauchy test, series n is equal to 1 to infinity 1 upon n raised to power p also diverges. So this is the proof of harmonic series which you used, which I told you earlier. So if anybody has doubt in this Cauchy condensation test, then tell me. Now I move to next nice result. Any doubt? Okay. So now come, yes. Okay. Now there is one more theorem. This theorem says if you have a series n is equal to 1 to infinity mod an converges, then this series n is equal to 1 to infinity an also converges. Actually, so far I told you only the positive series whose terms are positive, but there are also series. uh, I will tell you later after 20 minutes what are they actually series. Suppose you have this type of series. It means you can say this. So this will be 1 minus 1 by 2, 1 by 3 minus 1 by 4 and like that. So we have also series whose terms are positive, negative. So it says, so checking the convergence of this series we do by the Leibniz test. I tell you later after 25 minutes, but just now there are series whose terms are alternatively negative, positive. It says you cannot check the convergence of this, only you can check the convergence by Leibniz. It says if you consider all the positive series, so what will be the positive series of this? N is equal to 1 to infinity mod n becomes 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. This is the positive series of this. If you take this is, suppose this is series n is equal to 1 to infinity n. If you take all the positive terms and it converges, then you can say this previous alternate series in which positive and negative terms are present, this will also converge. The theorem is clear. If you are
Excuse
able,
me.
yes,
Sir, please explain again. Sir.
what I am saying, there are series whose terms may be negative or positive, like that 1 minus 1 by 2, 1 plus 3 or 1. In this way, it says right now you have no test to check the convergence of this type of series. Right now, later I will tell you. So it's this theorem says if you take all the positive terms like that 1 plus half plus 1 by 3 plus 1 by 4, all positive terms, and check this series. If this series mod an converges, so you can say this previous series, original series, that is series n is equal to 1 to infinity an also converges. About divergence, you can say nothing.
Sir,
Clear now?
excuse me, sir.
Yes.
Sir, it will converge to the same point or what?
एक्चुअली जब हम सीरीज डिस्कस करते हैं तो आवर मेन पॉइंट इज टू चेक द कन्वर्जेंस. अगर कन्वर्जेंस आ गया तो पॉइंट का हम बाद में चेक कर लेते हैं, क्योंकि एक्चुअली देयर आर ए लॉट ऑफ फिजिकल प्रॉब्लम इन विच वी चेक कन्वर्जेंस. कन्वर्जेंस चेक करने के बाद हम फिर देखते हैं कि वो अगर कोई सीरीज कन्वर्जेंस ही चेक नहीं कर रहे तो उसका तो सॉल्यूशन ही नहीं मिलेगा, तो वो प्रॉब्लम ही सोल्व नहीं हो रही.
ओके सर.
ओके, और लिमिट पॉइंट क्या होगा? दैट इज द डिफरेंट पॉइंट. अगर कन्वर्जेंस ही नहीं है तो हम कह देंगे ये तो प्रॉब्लम जो आपने की है ये एग्जिस्ट ही नहीं करे, इसका कोई सॉल्यूशन ही नहीं एग्जिस्ट कर रहा, क्या करें आगे।
Okay, sir.
Okay, so this is if series n is equal to 1 to mod n converges then this, so I am giving the proof of this because proof is simple and will be used by, will be in the proof of this is simple and can be done by using comparison test and other test. Suppose let series n is equal to 1 to infinity mod an converges. Or you can also see, I am not taking the at which point this is converges in infinite series. We are discussing only convergence or divergence. We are not discussing at which point this is convergence. So main point is convergence. Now, can you write for each n? Can I write this minus mod an is less than equal to an is less than equal to mod an? N is a real number, so you can write for all n, add mod an both all, mod an 0, an plus mod an, this is twice mod an. So you can write for all n. So here you can apply the comparison test. Series mod an converges, series n is equal to 1 to infinity mod an converges. This is given. So you can write, if you multiply each term by any non-zero real number, that series also converges. You can write this twice mod an also converges. Now by comparison test. By comparison test, you can say this series n is equal to 1 to infinity an plus mod an also converges. Now, you can write an is equal to an plus mod an minus mod an, or you can write like that, n is equal to 1 to infinity an for all n. This is series n is equal to 1 to infinity an plus mod an minus this. Now this is converges, and we know that subtraction of two convergent series is also convergence. So here we know that subtraction or addition, you can note down also, of two convergent series infinite series also converges. Hence, you can say this series n is equal to 1 to infinity n converges. But converse is not true. What is the meaning? There are chances that this series positive series converges, but previous original series, alternating series is not convergent. For example, if you take this series n is equal to 1 to infinity minus 1 की power n minus 1 n, this is you can write like that minus 1 की power n minus 1 an. So by Leibniz test, I will tell you what is Leibniz test. I will prove this question. By Leibniz test, this series n is equal to 1 to infinity minus 1 की power n minus 1 n. This is converges. An is converges, but if you take only the positive terms series, what will be? This will be series n is equal to 1 to infinity 1 by n. This is diverges by P test. So you can say positive series diverges, but alternating series is converges. So converse is not true. Clear point? I will do how it is converges alternate by Leibniz test. I will do when I will teach you the Leibniz test. So just remember right now for 10 minutes. If anybody has doubt, ask me. Okay.
सर
Now,
सर
yes.
एक्सक्यूज मी सर आपने इसके ऊपर एग्जांपल से ऊपर वाले क्वेश्चन में आपने ये बोला वी नो दैट सब्ट्रैक्शन और एडिशन ऑफ टू कन्वर्जेंट इनफाइनाइट सीरीज आल्सो कन्वर्जेस सर जो रिमार्क था उसमें तो ये था कि फाइनाइट नंबर
हाँ हाँ आई नो क्या था रिमार्क दो थे कि अगर फाइनाइट नंबर ऑफ टर्म्स आप ऐड और डिलीट करते हैं जब भी नेचर सेम रहती है और नॉन जीरो कांस्टेंट मल्टीप्लाई करें जब भी सेम रहती है, ये दो रिमार्क थे एक्चुअली में. दिस इज ए रिजल्ट, यू रिमेंबर, दिस इज एक्चुअली थ्योरम. इसका प्रूफ नहीं करवा रहा हूं, प्रूफ इज सिंपल. अगर आप इफ यू हैव टू सीरीज कन्वर्जेंट तो उनका एडिशन और सब्ट्रैक्शन इज आल्सो कन्वर्जेंट. दिस इज एक्चुअली a theorem. Okay, if anyone is divergent then you cannot say about the series which is obtained by addition or subtraction. Clear point?
ओके सर
This is actually a new theorem, so I am not doing this is not, this is trivial case, that's why I write we know that. Any other? Now we have more test, that is ratio test. Sometimes it becomes very easy to check the convergence of a series by ratio test or root test. So I am doing these two tests. First is ratio test. What it says, suppose an is not equal to 0 for all n. It should not be 0, and limit n is tend to infinity. It says you can write if it is positive, it may be negative positive, as a like down you can write is equal to L. General result I am saying, if you find the limit, this is L. It means if negative then take positive only. It says if limit of this expression comes out to be less than 1, then your series n is equal to 1 to infinity mod an converges. Some books it is written mod an, or we know that if mod an converges so an also converges. You can write n is equal to 1 to infinity an converges. So in some books it is written mod an, or in some books it is directly written that an. So don't confuse. Now second, if L is greater than 1, diverges. Third point, if L is equal to 1, it says we cannot make any conclusion. You can say nothing. So if you find the ratio test, take the ratio mod. If you find the limit of mod an plus 1 over anl, if this is less than 1, then series converges. If greater than 1, then series diverges. If equal to 1, so you can say nothing. Let us do one or two example on this. First example, suppose you have series 1 upon factorial n. Question is same, only check convergence. So here solution an is equal to 1 upon factorial n and an is not equal to 0 for all n. This is the condition of ratio test. Now limit n is 10 to infinity mod an plus 1 over an, because all are positive a1 a2, so you can directly write like that, because all are positive. So this will be limit n is 10 to infinity an 1 upon factorial n plus 1 upon factorial n. This is factorial. So here limit n is 10 to infinity, 1 factorial n will be cancelled out, 1 upon n plus 1. This is 0 less than 1. Clear? So it is less than, so by you can write directly by ratio test. Your series n is equal to 1 to infinity 1 upon factorial n converges. Let us do one more example. Suppose you have a series n is equal to 1 to infinity an. Examples are so easy. Questions are n raised to power n over factorial n. So here solution, take an is equal to n raised to power n over factorial n. An is not equal to 0 for all n, obvious, n is starting from 1 to 3. Now if you want to apply the ratio test, mod an plus 1 over an, all are positive, so you can write only mod an. So an plus 1, I think it will be n plus 1 over factorial n plus 1, raised to power n plus 1 over n plus 1 factorial. This will be n raised to power n over factorial n. Do some calculation, limit n is 10 to n. So this factorial will be cancelled out. So I am writing directly n plus 1, or I think this will be n raised to power n and n plus 1. I think this will. So this is limit n is 10 to infinity mod an plus 1 by n an. So this is do some work. calculation, n plus 1 will be cancelled out, so this will be n plus 1 n over n raised to power n. Limit n is standard, take n common here, so this will be 1 plus 1 by n, this is n, mod a n plus 1 over n, this is e, which is greater than 1. So it means greater than 1, so you can directly write by ratio test. You have whatever you have series n is equal to 1 to infinity. What was the series? N raised to power n factorial 1, n raised to power n factorial n diverges. So you can see how you can check in an easy way. Raghav Maheshwari, L is equal to 1. Any doubt? Raghav Maheshwari?
एक्सक्यूज मी सर
Yes.
सर वो नीचे से लास्ट थर्ड लाइन है ना
यही थर्ड, हाँ
हाँ सर इसमें लास्ट में लिखा है 1 + 1 बाय n तो इसमें तो 1 आएगा ना सर
किसने कहा?
तो 1 बाय इंफिनिटी 0
क्वेश्चन है, इसकी लिमिट
हाँ,
ई होती है, ये 10th में क्वेश्चन है, लिमिट में इसकी लिमिट ई होती है। अगर n यहां और यहां सेम हो जाए, अगर n से लेस देन है ये तो 1 होती है, इफ दिस इज लेस देन n देन 1 होती है, इफ इट इज n और ग्रेटर देन n देन इट बिकम्स e। राघव, दिस इज 10 क्वेश्चन।
ओके सर
जैसे इंडिटरमिनेट फॉर्म बन जाएगी आपकी ये 1 बाई इंफिनिटी, तो आपको लोपिथल रूल लगाना पड़ेगा। क्लियर?
ओके सर
ओके, एनी अदर डाउट? ओके, नाउ देयर इज वन मोर टेस्ट, रूट टेस्ट। What it says, let n is equal to 1 to infinity a n be infinite series. Okay. Limit n is 10 to infinity mod a n 1 by n is equal to L. Suppose. Find the limit mod a n raised to power 1 upon n. So it says if case first L is less than 1, same, then mod a n converges or sorry n is equal to 1 to, or you can write n is equal to 1 to an also converges. Second, if L is greater than 1, then this series n is equal to 1 to infinity a n diverges. Third, if L is equal to 1, same thing, we cannot make any conclusion. So important of root test, whenever in a infinite series an is given some power of n, then it is always better to apply the root test. For example, suppose this is given series. Series n is equal to 1 to infinity, this is given, this is. You can solve by ratio test also, a sandwich, whatever. But if you solve by root test, so this is so easy. So what I am saying, if an is some power of n, So always try to apply root test. What is mod an 1 by n? Then this will be easy. 1 by log n. Log n, this will be 0 less than 1. It means less than 1. This series n is equal to 1 by 2, 1 by log n converges. So you can see within one line you are getting answer. If you apply sandwich, yeah, by nth partial sum definition, yeah, any other method, even ratio test, this becomes lengthy. You can get answer, I'm not saying, but sometimes it is very typical. Ayush, any doubt? Ayush Anil Patil, is it clear? Okay. So now let us see one more example. Suppose you have this series n is equal to 1 to infinity n over n plus 1. This is n square. So again n square. So it is, you can do this question by ratio test also. But if you apply the root test, so within 2 steps or 3 steps you will get answer. It comes from the practice mod an 1 by n. So this limit n is 10 to infinity. The what will be this? This n over n plus 1. One power will be cancelled out. Or you can write this is limit n is 10 to infinity 1 upon 1 plus 1 by n. And take common and cancel out. So finally, limit n is 10 to infinity mod an 1 by n. So this is limit n is 10 to infinity 1 upon 1 plus 1 by n. So this is 1 by e, which is less than 1. Again, you can say directly by root test series n is equal to 1 to infinity whatever n over n plus 1 converges. Anybody, sir, can you show the statement of test again? Okay, Anubhav. This is.
सर
Yes.
सर अगर हम लोग ये टेस्ट 1 अपॉन n रेज टू द पावर n के ऊपर लगाएंगे तो लिमिट n टेंड्स टू द पावर इंफिनिटी 0 हो जाएगा जो कि लेस देन 1 होगा।
किस
तो
पे?
उसके 1 अपॉन n रेज टू द पावर n
1 upon
n रेज टू द पावर n
1 upon n raised to power 1 by n. Yeah.
नहीं 1 अपॉन n रेज टू द पावर n।
अच्छा, just wait. आपको यू सीरीज, ये सीरीज है, यू आर सही।
यस
हाँ,
तो इस पे लगाएंगे तो 1 अपॉन n 0 दे देगा फिर।
you are applying, if you have this type of series, so you are saying that sir, agar if I apply 1 by n, this is 1 by n. Okay?
Yes.
This will give you the 0. Okay?
Yes.
So this series n is equal to 1 to infinity 1 n by this will be converges. So what is the problem?
1 अपॉन n इस पर n डाइवर्जेंस है कन्वर्जेंट।
भैया ये अलग है, वो सीरीज अलग है। इसको ओपन करोगे तो क्या आएगी सीरीज? 1 बाई 1, 1 बाई 2 स्क्वायर, 1 बाई 3 क्यूब है। और अगर आप इसको ओपन करेंगे 1n स्क्वायर को, ये आएगी 1 1 प्लस 1 अपॉन 2 स्क्वायर प्लस 1/3 स्क्वायर आएगा या क्यूब आएगा. सीरीज इज डिफरेंट.
Okay.
Getting point?
Yes, sir.
Any other thing?
No,
Oh.
sir.
Now come to the new thing which I told you, alternating series. What it say? A series whose terms are alternatively positive and negative for example, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, like that. Or this you can write summation n is equal to 1 to infinity n minus 1 is called alternating series. So now question again arise, how to check the convergence of this series. You cannot check the convergence by previous methods because they are for positive series. Here our terms are becoming negative positive. So there is one test that is known as Leibniz test. This is for this type of, for checking the convergence of this type of series. It says if an is decreasing and limit n is tend to infinity, an is equal to 0. The term will approach to 0 as n is tend to infinity, then this series n is equal to 1 to infinity minus 1 की power n minus 1 an converges. So if you want to prove the convergence of alternating series, you need to show two things. An will be decreasing, only positive terms, be careful, and nth term must be 0. Series is written in this form. So this is Leibniz test. Now example 1. Suppose you have this series. Question is check convergence. So again, this is alternating series. You cannot apply ratio test, root test. So here, an is equal to 1 by n. So, not clearly. Solution. We have an is equal to, clearly an is decreasing because n is increasing, so an will be decreasing, and limit n is tend to infinity 1 by n is equal to 0. So you can directly say by Leibniz test, this series n is equal to 1 to infinity minus 1 की power n minus 1 n converges. Which I told you, so this is the proof of convergence of this series. I took this example when I told you if you have a series and take the positive term, this is converges, then series n is equal to 1 to infinity an converges. Now take one more example. N is equal to 1 to infinity minus 1 की power n minus 1 an. Suppose you have this series. N square. So here again do the same exercise. An is equal to 1 by n square. Clearly an is decreasing because if n increasing, n square increasing, so 1 by n square decreasing, and limit n is 10 to infinity an. This is limit n is 10 to infinity 1 by n square. This is 0. So why you can write Leibniz test. Your series n is equal to 1 to infinity minus 1 की power n minus 1 n square converges. So it means if you take both series alternating, these are converges. But if you take the positive series of this is will be 1 by n, and positive series of second will be 1 by n square. But this is diverges and this is converges. So here alternating series converges, but in one case, if you take the series of positive terms, diverges, and other is converges. The question arises, what is this? So new definition comes into the picture: absolutely convergence and conditionally convergence. One is called absolutely convergence, other is called conditionally convergent. I will tell you that definition in tomorrow lecture. So today is up to here. If anybody has doubt, ask me.
सर
Yes.
ऑल्टरनेटिंग सीरीज का स्टेटमेंट एक बार दिखा देना.
हाँ, why not? This is.
सर
Yeah.
सर
Yes, हाँ बोलिए.
सर ये लास्ट में जो लास्ट लाइन लिखी है कि 1/n डाइवर्ज हो जाएगी और 1/n स्क्वायर कन्वर्ज हो जाएगी,
हाँ.
लास्ट लाइन जो है बिल्कुल वो कैसे
हाँ.
लिखी है?
अरे
P
भैया
test.
ये पॉजिटिव पी टेस्ट से कर दो ना.
अच्छा पी टेस्ट. अच्छा
एन की पावर पी
हम्म,
सीरीज 1/n की पावर पी. दिस इज डाइवर्जेस if p is less than 1, converges p is greater than 1. I will tell you in next lecture.
But sir,
I will
in this
start
case, p
from
is
here.
equals to 1.
Yes.
हाँ तो लेस देन इक्वल टू है ना 1 उसमें.
हाँ, लेस देन कर दिया ना इक्वल टू बेटा.
लेस देन
ये
But
इक्वल टू
sir,
लिखा हुआ है.
but sir, if we sum up it, it is giving some constant value.
कांस्टेंट वैल्यू से ही तो आ रहा है. ये वो बन जाएगी ना कांस्टेंट सीरीज 1 1 1 1 जीपी विद कॉमन रेशियो 1. तो वही तो प्रूव करा है मैंने कोजी कंडेंसेशन टेस्ट से. वहीं से ही तो प्रूव करा डाइवर्जेंस कर रही है ये तो मैंने उससे भी प्रूव करा है. एसएन इफ पी इज इक्वल टू 1 तो 1 प्लस 1 प्लस 1 अप टू n टाइम्स n हो जाएगा और लिमिट n इज 10 टू इंफिनिटी एसएन ले लोगे तो इंफिनिटी ये डाइवर्ज कर लो. इसके तो 2 3 टाइम्स प्रूफ दे चुका हूं. आई हैव गिवन. साइलेंट निमित कर म्यूट योर. एनी अदर डाउट?
Sir, can you please open example 1, first example of today's class?
Yes. This is.
Sir, first example of today's class, Cauchy test or Cauchy condensation test.
Okay, okay. I am coming to. I will also share this PDF, but I am saying if you have any doubt, reach example. This no. This was absolutely. I think this is third case. Third case या
नहीं,
second or
जनरली डाउट इसमें ये है कि
one.
केस 1 है, केस 1
ये है कोची टेस्ट का. अच्छा केस 1
तो
कम टू
जैसे
केस 1.
इनमें सर हम डायरेक्ट ऐसे लिखते हैं कि देखिए r लेस देन 1 है तो ये कन्वर्जेंस, या इसको भी प्रूफ करके दिखाना है पहले कि r लेस देन 1 है तो
बेटा ऐसा है, अगर आपको 1-2 मार्क्स में है तो आप डायरेक्ट जो ज्योमेट्रिक सीरीज है वो स्टैंडर्ड सीरीज है, तो उसका रिजल्ट आप यूज कर सकते हो. अगर 2-3 नंबर में आता है देन आपको वो दिखाते नहीं पड़ेगी. उसको दिखाने में भी 1 मिनट नहीं लगता.
ये सर तीन
वो मैंने प्रूफ कर चुका हूं मैं. लेकिन वो 2-3 नंबर में 3 नंबर में क्वेश्चन आ रहा है तो आपको अच्छा है कि वो प्रूफ करें आप.
ओके सर.
1-1.5 नंबर में आ रहा है तो उसमें क्या प्रूफ करोगे. यू कैन यूज डायरेक्टली आंसर.
ओके
ओके
सर
आर्यन.
लास्ट एग्जांपल फिर से बता दीजिए. ये लास्ट एग्जांपल बताया.
ओके last example. I'm coming last example. This is last example.
सर इसका लास्ट पार्ट जो है सो बाय लेबनिज टेस्ट के बाद से
यहाँ
हाँ सर इधर.
ओके.
सर आवाज नहीं आई थी आपकी.
Now any other doubt? Is it okay?
सर आपकी आवाज नहीं आई थी. सॉरी.
ओए कोई इंटरनेट चला गया होगा यार. Do you have any doubt?
नो सर ठीक ठीक.
Okay. Now I am stopping my lecture.
Sir.
आयुष.
सर प्रैक्टिस कौन सी बुक करनी है.
यस पुलकित. प्रैक्टिस के लिए लिमाए घोर पड़े कर लीजिए और मैंने असाइनमेंट भी भेज दिया है
तो
आपको,
सर वो
भी कर
बुक
लीजिए.
की सॉफ्ट कॉपी आपने प्रोवाइड करवाई है क्या.
नहीं प्रोवाइड मेरे पे है नहीं.
थैंक यू.
आप